Git is a program that supports the management and workflow of one single project. The Caretaker in a project house is a management system for many and any number of projects. Therefore, the Caretaker in a project house is much more complicated and difficult to learn and to use than Git, right? Wrong. Working with many projects makes even the workflow of one project much easier. This is what we are going to explain next. We will demonstrate how to work with the system in real-life situations and how to solve daily problems. So far, we mainly talked about the definition of a project, its life cycle and its appearance in the archive and workshop. But now we focus on real-life problems we can solve by using projects as atomic building units. Recall that the Caretaker in a project house concept of a project defines it as a unit made of a description, an optional active project tree, and a possibly empty but unlimited list of backups. When the project tree does not exist, we say that the project is not in the workshop and not active. And in the GUI, this is displayed as a blue unit with a project description and a list of backups. When the project is active, on the other hand, it is displayed in red, and we also say that the project is in the workshop, which means that the home directory, named after the PID FB17, etc., exists under the project house root and contains all the files and subfolders. In the sequel, we use a smaller and more iconic picture for a project. On the left, the version for the inactive project with description and backups. On the right, the active project with an additional active project tree in the workshop. Sometimes it is useful or even necessary to develop a project in different directions or branches. Suppose we have a software project in a pretty good shape. Everything is running and works as expected. The program may even be good enough to be used in production, or it may even be sold. At such a state of the project history, we should make a backup. We give it the subtitle version 100. A good software product usually needs maintenance, especially if it is successful. Suppose we now realize a need to do three things. Some little bugs have been identified and need fixing. Second, customers request some new features. And third, the program should be ported to another machine architecture so that it runs on more devices. All three improvements are pretty independent from each other. They can even be implemented by three different developers. So we create three duplications of the original project, and each of these duplicates becomes a separate development branch. By a duplicate, we mean a clone of a project, which is pretty much identical, except that it has a different PID. We already know how to create such a duplicate. The quickest way is to restore and clone the last backup. That gives us a new project with a different PID and the old title preceded by a clone prefix. We can then activate this project and edit the title. The other way to create a duplicate project is creating a new project, activating it so that it can be modified in the workshop, and then copy the file tree of the original project into the new project. Finally, we can make a backup to store its initial state. In both versions, we end up with a new project pretty identical to the original one. Note that the restriction of the PID named home directories in the same workshop location now pays off. No matter if the duplication is obtained by a clone or a file tree copy, all the links that held the original project are still valid and point to the same items. And we could repeat the process to obtain 4 almost identical projects with different PIDs. We can modify, edit, backup, close, discard. We can just develop each branch on its own and independently. And once any of these branches have been perfected, they can be merged again. For example, into the original project. At each time, every project is simultaneously and fully accessible in the workshop. By grouping all branches of a project under one location in the archive, we also have a nice order and overview. In the Caretaker and a Project House approach, a project is a relatively primitive unit with an optional file tree, a description and a list of backups. The current file tree can be backed up and the project can be closed, which removes the file tree. And then it can be activated again, which copies the last backup into the home directory of the workshop again. That is pretty much it. The progress is only one directional in the sense that it is not possible to reactivate an older backup, at least not in the same project. But this relative primitivity is compensated by the possibility to work with any number of projects. That makes the system as a whole very powerful. In a project house, one project can be duplicated and multiplied into several projects. These projects can interact and they can even be merged again. In Git, on the other hand, the project is always limited to being one project. So for any kind of diversity, we need to introduce new concepts. For example, let us maintain the same previous example project with Git. There is a working tree and the Git repository in the hidden .git folder. As in a Caretaker, you can pile up a stack of backups or commits, as they are called in Git. And here as well, each commit is a snapshot of the current active working tree. And in Git you can check out, which means restore any of these commits, not just the last one. You can also branch in Git. The default is always the so-called master branch. Next to that, you can make up your own branches and develop the project in various directions. And at any point in time, you can merge any two branches again. But you need to know all the commands and their effect in Git. The whole is quite a complex subject and has a steep learning curve. And in Git, only exactly one branch is accessible as an active working tree. You can compare two branches in Git, but never as immediately as in the Caretaker workshop. Instead, you will need to learn the commands that do all the action. In our approach, projects can be made of other projects. One project can be divided into many, and many projects can be combined into one. For example, an author wrote a set of short stories, each one maintained by a separate project in a project house. At some point, a selection of these stories can be combined into a book, which is another project. In the Caretaker, you can use projects as building blocks for other projects. And this is a very powerful feature, especially in combination with symbolic links. Let us return to our previous Caretaker user, who is writing a series of travel guides. Let us focus just on two: a visit to Warsaw and a guide to Estonia. Suppose this is done in HTML and for beauty and consistency, the travel guides all use the same layout, which is given by a CSS style sheet. Of course, we could use two equal CSS files in both projects. But when we make changes in the style sheet, we always need to make the changes in all the copies, and that is not an elegant solution. In a more professional approach, we create another project, say HTML and CSS templates, and put the style sheet in there. And each travel guide project that uses a style sheet has a symbolic link to that file. That way, everything is always up to date. Let us explain this in a little more detail, because the strategy in this simple example is a key to a really powerful project management. We have 3 projects, and this is how it looks in the archive: 2 travel guides and 1 for the default templates. All 3 projects should be active, so we have at least these 3 projects in the workshop. The project 0F7D standard.html and CSS templates has two files, the style sheet standard.css for all other projects and a default.html file, which is the default blueprint for every main HTML file in any travel guide project. The 25cc project, A Visit to Warsaw, has a main.html file, two pictures in a subfolder and the same style sheet standard.css. The 65F5 project, A Guide to Estonia, is in an early state and just comprises main HTML and the same standard.css again. The important thing now is that there are not three but just one standard.css file, which lives in the HTML and CSS templates project. The other two instances are not separate files but symbolic links to the original and so-called target file. The symbolic links are just aliases for the target and behave very much like the original. But they are linked to the target, which means that any change to the standard.css file in project OF7D is also a change in the linked instances. That way we can manage and modify the layout for all travel guides projects by modifying just the one file in OF7D. Suppose we like the state of the visit to Warsaw and make a backup. This backup then stores the full standard.css file as it is. Any later restore and clone of the backup also recovers not just a link but that file. When after the backup the standard CSS is changed, the current state of the visit to Warsaw is affected accordingly, but the backup will always remain in the state at the time of the backup. Again, let us consider the example with two travel guide projects and the one project holding the style sheet. Let us create the symbolic link from standard.css under the Warsaw project to the target file. The HTML and CSS templates project contains an HTML and the CSS file, which will be the target for our symbolic link. The Visit to Warsaw project contains a main.html file and a pics folder with two pictures, but no standard.css yet. This is what we are going to create. The easiest way to create the link is a modern file management program like the Windows Explorer or Linux Dolphin, which we use here. We right-click, choose to create a new link and then select the target. Afterwards, the link is created. Alternatively, we can use the command options to create symbolic links. ln-s in Linux and macOS and mlink in Windows. The Caretaker GUI does support the display of symbolic links very well. After creation, we see in the file tree of the Visit to Warsaw project that it has a standard.css, which is not just a file, but a link to the target under the HTML and CSS templates project. The target of symbolic links is always mentioned after an arrow symbol. The Caretaker also identifies broken links and shows according alerts. Suppose we have created the two links from the two travel guides project to the standard.css file. The links only work well if the target is present. Suppose now we close the HTML and CSS templates project. That would remove its files from the workshop, including the standard.css file. If we now take a view into the workshop, we can see that only the two travel guide projects are still active. But we also see an added improper items list, which tells us that the two links are broken now. The same is shown when we view a single project with a broken link, for example, the Visit to Warsaw project. Now, the standard.css item points to a broken warning. Of course, for the repair of all the broken links or improper items, it would suffice to activate the HTML and CSS templates project again. Afterwards, 3 projects are active in the workshop and the warnings disappeared. Recall that the Caretaker is a program and command that you once install on your computer. It is not important for the user where the program code is stored, as long as it is available to be used. A project house does have a defining location in the file system. It lives under the so-called project house root, which is home yo project house in this example. The Caretaker is used to create and maintain such a project house. This one, for example, was created under the directory /home/yo with a call of Caretaker init house. You can also use a GUI for the project house in the browser after calling Caretaker start server. All content of a project house is located under its root. Moving the entire project house maintains this structure and does not change the content. For example, suppose you opened a project house under Sandbox for a first encounter. You created some projects and after a while you decide that you would like to keep everything and start to use it seriously as a daily tool. But for your real work, you use the series directory. If running, you can stop the GUI server. You then take the entire project house and move it from the Sandbox into the series folder. You start the GUI again by calling Caretaker start server on the new root and everything is working again. In the same fashion, you copy a project house and use it on another location, even on another machine that also has a Caretaker installed. When you really work with project houses, you should make it a habit to back them up from time to time, so that nothing is lost in case of a computer crash. You can make such backups by copying the project house root onto other media, say a DVD. You can also work with several project houses at the same time. In this picture, there's one project house on the left under Home Yo Sandbox and another one under Home Yo Series. You can start a GUI server on both instances simultaneously by using different port numbers and then open 2 browser tabs or windows and point them to the 2 URLs. You can also import one project house, which means all its projects, into another one. For example, for the import of the left into the right one, we use the command Caretaker import house with one import argument for the imported project house and a root argument for the importing project house. After this import, the left project house can safely be removed because all its projects are now added into the right one. Recall that the Caretaker in a project house defines a project as a unit comprising a description, an optional project tree, and 0 or more backups. We can view such a project in the browser. For example, this one is active, so it has a project tree and 2 backups. We can work with this project, but the thing itself needs a project house and Caretaker to exist, because its components are stored in a hidden storage system. But we also want to be able to export such a project and have it available outside the project house. For that purpose, the Caretaker has an export command. Suppose we have this example project active in our project house. And we now want this to be exported out of the project house into a directory named, say, exports. We open a terminal and move cd into the project house. Then we call Caretaker export with 2 arguments, the PID of the project and the destination directory, which is /exports. It is not necessary to list all the 40 digits for a PID. You only need to specify the first ones, enough to uniquely distinguish this project from all other projects in the project house, which is usually achieved after 2, 3, or 4 digits. In this case, the first 4 digits of the PID are FB17. The Caretaker export call with the specified PID will create a full file tree representation of the entire project under the Exports folder in a folder named after the same PID, FB17. As a project itself, there are 3 parts under this folder. The project description is given in 2 formats, as a JSON object in project.json and as an HTML page project.html, which again displays the entire project with all its parts. The optional file tree of the active home directory, which is present here because the project was active. In the export, this folder is called Home, and it contains exactly the file tree under FB17 in the workshop. The backups here too, each one under the SHA-1 value of its file tree. By the way, this is how the content of project.json looks in Firefox. And this is the content of project.html in the same browser. The yellow buttons refer to the home folder and the 2 backups. For example, the home button shows the content of the home folder, again in Firefox. The Caretaker also has several export command versions for the export of multiple projects. There's a just mentioned export by PID. One command to export all projects with a specified tag. One exporting all projects of a specified creator. And finally, an export all command for all projects in the archive at all. For all these export commands for multiple projects, the output result has the same format. For example, let us take the project house with 6 projects in the archive, and we want to export them all. Again, we assume that next to our project house root folder, there's another folder named Exports, which is the export destination directory. We open a terminal and move cd into the project house root. And then we call Caretaker export all with the additional argument for the target directory. As a result, the exports folder now holds a new root folder named project house export. In it there are 6 folders, each one the export of one of the 6 projects. The format and structure of each of these exports is the same as a single project export before. And there is an index.html file which holds an exported version of the archive and looks like this in the Firefox browser. Each of the 6 project lines in this overview is a hyperlink to the according project.html file of the according project. That way, we can browse through the entire exported project house and all its contents. Be aware, however, that the redundancy of our project house storage is now destroyed. Multiple occurring files now occupy storage space for each of their instances. During an export, the result may be an explosion in the demand of the storage space compared to the space of the project house.